The science behind why lemons float and limeys sink. Nature often presents phenomena that seem simple on the surface, but reveal fascinating scientific principles upon closer examination. One such curious observation is that lemons float in water while limeys sink. At first glance, lemons and limeys appear quite similar. They are both small, round citrus fruits with similar densities and comparable compositions. However, their contrasting behavior in water can be explained through the principles of density, buoyancy, and structural differences. The principle of density. Density is the measure of mass per unit volume. An object will float in water if its density is less than that of water, which is approximately 1 gram per cubic centimeter gram per cubic centimeter. Conversely, an object with a density greater than water will sink. The ability of lemons to float and limeys to sink indicates a subtle difference in their densities. Lemons have an overall density slightly less than water, allowing them to float. On the other hand, limeys have a density just slightly greater than water, causing them to sink. The role of air pockets. One significant factor contributing to the buoyancy of lemons is the presence of small air pockets within their porous rind. These air pockets reduce the overall density of the lemon, making it less dense than water. Limeys, by contrast, have a thinner and denser rind with fewer air pockets. This structural difference means that limeys have less buoyant force acting on them, resulting in their tendency to sink. Composition and structure. While lemons and limeys are similar in size, shape, and internal composition, their structural differences play a crucial role in their behavior in water. Lemons tend to have a thicker, more uneven rind with a spongy texture that traps more air. This contributes to their lower density. Limeys, with their smoother and thinner rind, lack this spongy layer, resulting in a higher overall density. Experiments and practical applications. This simple observation can be tested at home with a bowl of water and the two fruits. The experiment not only demonstrates basic principles of physics, but also encourages curiosity and exploration of natural phenomena. The differing buoyancy of lemons and limeys has limited practical applications, but serves as a fun example of how small variations in nature and have noticeable effects. Broader implications. The floating lemon and sinking lime provide an excellent teaching moment about density and buoyancy, concepts that are foundational in physics and engineering. These principles are also critical in real-world applications, such as designing ships, submarines, and other objects that rely on managing density and buoyant forces. Conclusion. The observation that lemons float while limeys sink may appear trivial, but it opens a gateway to understanding fundamental scientific principles. By examining the densities, structural differences, and buoyant forces at play, we gain insight into the subtle yet significant variations that differentiate these two citrus fruits. This simple phenomenon reminds us of the richness of the natural world and the importance of curiosity in uncovering the science behind everyday occurrences.